train wheels follow a curved track? Let's find out in this video. It will be easy to understand with 3D animation. This is a train coach and 2 bogies. Coach is fitted on the bogie frames. Wheel sets are connected with bogie using bearing. Thus, train weight is supported by the wheels. We already mentioned before that wheel set is actually 2 side-by-side wheels joined with center axle. It always rotates as a single unit. That means one side wheel cannot rotate faster than the wheel on the opposite side. Bearing on both ends helps it to rotate quite freely while supporting the total weight on the wheels. A rail wheel set can follow a curved rail without any external steering force. The secret is in its design. You probably know that rail wheel's outer surface is not completely cylindrical. If it was, then wheel set could be able to follow straight rail lines, like a car wheel rolls on road. But when the rail's curved section begins, there will be no steering force to turn the wheel set to follow the curved rail. This means a cylindrical shape cannot follow a curved rail track. That's why rail wheels are not cylindrical in shape. Rail wheel's outer thread section is slightly semi-conical. This is a cone, and this is a semicone. On a plane surface, a semicone cannot roll straight. You can clearly see here. At green color marked side, circumferential length of the circular section is smaller. Opposite side marked with violet, this side circumferential length is larger. Or you can say green side diameter is smaller and the opposite side diameter is bigger. At same rolling speed, larger section will try to cover more distance than the smaller side. While rolling, a semicone always turns towards smaller side. A rail wheel set follow the same physics principle. Let's assume this wheel set running on this rail track. Thread section of wheels, which is in contact with rails, are marked with red color for better understanding later. Both sides the running thread diameter are same. That means this wheel set will act like a cylinder and will keep rolling straight over the rail track. Did you ever notice a rail track carefully? Rails are not installed vertically straight. Rails are slightly tilted inside. This track design increases contact surface between rail and wheel, which in turn provides better traction for the wheels and helps to reduce wear and tear at contact points. Normally, a wheel set seats on a rail track like as it's shown here. Semi-conical shape of the wheel thread section and this rail track design also provides an important characteristics. When an object is at rest position on a slope, reaction force will be perpendicular to the contact surface. These are the 2 components of that reaction force. If this angle is theta, then vertical force component is r cos theta. And the horizontal component is r sin theta. If this slope angle changes, the theta value will change too. If angle increases, the r sin theta value will increase too. Conversely,